Hello, today is Monday, August the 16th. I'm Rick Gagne from Ampco Manufacturers doing a test, first of all, to mimic the hex-shaped indentations that are occurring around the nut on these the face plates. So what I've got, first of all, here, I have a torque wrench. It's a Titan torque wrench. It measures in Newton meters or inch pounds. I'm going to use the Newton meters scale. I have the nut attached to the switch. The switch is one of these that has been provided to me. So I have this clamped in my vise. I have the material stack-ups on the end product, which are 1/8 inch black acrylic. I have, on this one, I have Noryl, which is 20 thou thick Noryl, and it has a 5 thou adhesive. For the purpose of this test, I haven't removed the paper off of the adhesive. I just left it not attached so that I can do this test on multiple materials without too much trouble. So I think I can mimic it pretty well. If if more tests are needed, then I could do something where I would apply the adhesive. So what I have done here, I'm seeing the puckering beginning, and I've tightened this nut with the torque wrench to 4 nanometers. So I'm going to go to 5 nanometers right there. And I am seeing the puckering similar to the pictures that I was provided. So this is my control sample that will show what we are. Now we're going to continue on. I'm going to pause this and set this up on some other materials. One more thing, I have on all of my material samples, I have 2 holes. So to see if the hole size matters. So I have the normal ones are exactly 0.5 inches, and then I have some holes at 0.48 inches. So I'll see if that makes a difference. So I'm going to do that first. That's going to be my first change. So this is the effect at the 0.48 inch hole. Quite a bit of puckering. It doesn't seem any better than the 0.5 inch hole, but I'll keep going with other materials. One of the other things I'm going to vary in these experiments is the thickness of the adhesive. So I have the standard adhesive, which is a 5 thou thick. I also have a thinner version, 2 thou thick. So this is the same Noryl from the first test. It's the same pressure. I'm going to use 3 nanometers, 3 Newton meters rather, 3 Newton meters. And this one is the thinner adhesive. So I'm still seeing the puckering. So I'll keep on going and see if we can find a difference. And this image is of the Noryl with the 2 thou adhesive and the smaller hole. That would be the 0.48 inch diameter hole. The picture just before was of a 0.50 diameter hole. Next, we're going to try some other materials and see if we can see a difference. This one actually looks quite good. So the next material we're using is FR700. This is the original material we've been using on these panels for a number of years. So this is the idea of going back to it. It seems to have some pressure. That's still, again, 3 Newton meters of pressure, which is a good amount, I'd say. So that is on the 0.5 inch diameter hole. This image is the same FR700 material. It has 5 thou adhesive, but the hole through the material is 0.48 diameter, 0.48 inch diameter, as opposed to 0.50 from the last test. It actually looks quite good. I do now see the difference between the Noryl and the FR700. It's an obvious difference. And while I have this set up, what I thought I would do, because I didn't see any puckering, is I torqued it more. So instead of 3 Newton meters, I got it to 4. And I'm going to try it to 5. So I can start to see a little bit of puckering with 4 nanometers. So I'm going to see if I can crank it even more. That's 4.5. Yeah, so at 4.5 I'm getting puckering. So I wouldn't go anywhere near on any of the material past 4, but 3 seems to be the good amount to torque it. This is the FR700, this time with a thinner 2 thou thick adhesive. This one is in fact has a laminate over the FR700. This has a matte Lexan laminate, but I can see that it's tearing. So I think I'm just going to eliminate that from the test. The screw is tearing it even at 3 Newton. This one is the FR700 with the 2 thou adhesive. So it also looks good. That's again 3 Newton meters of pressure on the torque wrench. And this is 4 Newton meters of pressure on the same FR700 material with the 2 thou adhesive. Incidentally, the hole size is 0.5 inches. I don't see any puckering, so I'm going to torque it more and see at what torque I can get it to pucker. 4.5. So there's a little bit of puckering. I'm at 4.5. It doesn't seem to want to let me get any more pressure than that because it's spinning, probably just biting into the material at this point. This is the one showing the same FR700 material with 2 thou adhesive, but through the smaller hole, the 0.48 inch diameter hole. So at 3 Newton meters, I'm seeing no difference. So I'm going to try to crank it more. Well, let's see if I can get this to 4 before it starts to spin. That's to 4 Newton meters. So slight puckering, but really not much is visible. So we'll call that a pretty good test there. I'm going to try one more material combination. This one's a little bit different. And also, but before I do that, I thought I would show what I'm doing when I pause it. So I'm going to do this one time. I'm going to show my process of changing over materials. So this material it's back to the Noryl, but you can see it has a nice matte finish on it. So what I've done here is I've laminated a 3 thou Lexan matte finish material over top of the Noryl. So it really gives a finish very, very close to the FR700. So now let's just see what happens here. I like the finish of it. I'm a bit concerned of what's going to happen when the nut turns on it. So I'm going to try to hold this still. See what happens when I get up to 3 Newton meters. It's going to take a couple of turns here. There's 3 Newton meters. That is on the Noryl. But one of the things I notice is that the nut grabs into the laminate, the 3 thou, the thin laminate on top, and it kind of makes a mess of it. So I'll pull that apart and we'll conclude our tests. Thank you.